Good day, grade 12 learners. Welcome to today's Physical Sciences Paper 2 revision lesson. My name is Dimpo Rampora, and this lesson is brought to you by the Northern Cape Department of Education in collaboration with Papper Research and Development. So as we know that we are going to be writing a Physical Sciences Paper 2 pretty much very soon, what are the things that you need to look at? The first thing that we are going to start with is just to look at the layout of the question paper. We know that you're going to be given 10 multiple choice questions that will be equivalent to 20 marks. And then you're going to be given structured questions, which will be about 130 marks. And you are going to sit for also a 3-hour paper, and the total of the paper is 150 marks. Now, another thing that I quickly want us to look at is the knowledge areas that will be assessed in this paper. So you are going to be assessed on chemical change, which is about 92 marks. As you can see, it is the knowledge area that carries a lot of marks, so that you must make sure that when you practice, you look more into mastering chemical change. And then we also have matter and material, which is going to be about 58 marks, which is also a lot of marks that you can get from that knowledge area. Also, we know that the total will give you the 150 marks that we were talking about. Now, let's look at the layout of the question paper. Now, normally we're looking at the layout, looking at previous question papers. We know that you'll be given a multiple choice question that will consist of all the other topics that will be covered, which are organic molecules, physical properties of organic molecules, types of reaction, rates of reactions, chemical equilibrium, acids and bases, galvanic cell, as well as electrolytic cells. So we are not going to look at how many marks each question is going to be, because it will vary depending on the question paper itself. Now, the first thing that you are going to do before you start answering questions on the question paper, I always advise learners to make sure that they read the instructions. Please make sure that you read the instructions carefully and you do follow the instructions, especially things like rounding off to 2 decimal places, things like using the data sheet that is attached. Make sure that you go through the exam instructions very, very carefully, right? Now, without wasting any more time, we are going to look at question 1, which is the multiple choice question. I'm not going to be answering any multiple choice questions. However, I will be giving you tips on how to answer multiple choice question. Now, the first tip I want to give you is to make sure that when you see the multiple choice question, you're going to read the question very carefully with understanding. Then when you are done, you try to eliminate any wrong answers that you're going to come across the first time you see them. You are going to then look for any keywords that will help you remember any concept that you have studied. And then the next thing that you're going to do, you're going to use your logic and reasoning to choose the correct answer. Now, the very much important tip that I want to give you is also to make sure that you manage your time very effectively. Please do not waste time answering questions that you know that you are not familiar with them or you are not sure of them, all right? Make sure that you use a reasonable amount of time in each question. The next thing I want you to do is to look at SI units as well as conversions. They're very important. They can give you clues as to which multiple choice is, or rather which option is correct in the multiple choice. The next thing that I want you to do is to review your answer. The moment you have now selected the correct option, the next thing that you're going to do is to review that option to say, why are you saying it is the correct answer? The next thing I want you to practice from previous question papers. Please make sure you practice multiple choice question, because I know most of you like practicing the long questions as well as the calculations, but we leave out the multiple choice questions. So just go through them. You will see that most of them, some of them are repeating themselves, and some of them, they are more similar as you go about them. And then the last thing, please make sure to never leave a multiple choice unanswered or unattended. You rather guess what the answer is rather than leaving it unanswered. Now, that is all about question 1. We are quickly going to look at question 2, which is normally organic molecules. Now, over here, I've given you a summary of what you need to know when we are looking at organic molecules, which is question 2. Now, we know that we are looking at the homologous series and the functional group, the general formulas, okay? These 3 are the most important for now. So I know that most of you know about alkanes, alkenes, alkynes. You are confident when it comes to these three. But the problem comes when we are dealing with the aldehyde, the ketone, the esters, as well as the carboxylic acids. I know haloalkanes, they are not that challenging, as well as alcohols, they are not that challenging. But the challenging are the first four that I just indicated to you now. Now, what is it that you need to look out for? You need to be able to look at the structural functional group of each. As you can see, an aldehyde, you have a double bond of oxygen attached to the first carbon and then with a hydrogen on the side. You must remember that the moment you see that, that will be your aldehyde. And then over here, your ketone, the moment you see the oxygen that is attached to a carbon that is at the center of two carbon atoms, then you know that you are dealing with the what? With a ketone. Very much important to remember that. And then the next one is an ester. You just look at the co, C-O-C-O. The moment you see co, you know that you are dealing with an ester, right? So you need to be able to master how to recognize, how to identify the homologous series as well as the functional group. And then lastly, the carboxylic acid almost looks like an aldehyde, but the difference is that in the aldehyde, you don't have the oxygen in the first carbon, but in the carboxylic acid, you can see you have the oxygen that is attached to a hydrogen and also attached to the first carbon atom. Alright, when you are done, the next thing that I want you to make sure that you get it very right is the names of the functional groups. I know that you know that the homologous series is an aldehyde, the ketone is an ester, is a carboxylic acid. But the moment the examiner says to you, write down the name of the functional group, that's where most of us rather confuse the homologous series and the functional group. When they ask you about the name of the functional group, you know that for aldehydes, the functional group is the formyl group. For ketones, the functional group is the carbonyl group. And then for esters, you can see it does not have any name of functional group. And then carboxylic acid, you can see we have what we call the carboxyl group. It's easy to remember this one because carboxylic acid for carboxyl group, it's easy to remember that. And then the other one that I want you to add is for alcohol. Alcohols, the name of the functional group for alcohol is the hydroxyl group. Why is it hydroxyl? Because of the hydroxide that is attached to the carbon atom. Very much important to take note of it. If you are able to do that, the next thing that I want you to master is to look at the general formulas. Master the general formula, master the homologous series, master the functional group, then I promise you that you are not going to have any difficulties when you are dealing with this question. The next thing that I want you to also remember as you are practicing your previous question papers in this section, be able to identify if the organic compound is either saturated or unsaturated. Remember, saturated compounds are organic compounds that consist of single bonds between their carbon atoms. And then unsaturated compounds, they consist of multiple bonds between their carbon atoms. Remember that difference, okay? Then when you are able to do that, then you are good to go with this one. Still on question 2, I want you to be able to formulate, to look at the formula, the different types of formulas that we have. Because when you are given an organic compound, you need to be able to identify if you are given a structural formula, a molecular formula, or a condensed structural formula. Why is that important? Because that is the language that the examiner is going to use, okay? The examiner can say to you, write down the structural formula, write down the condensed structural formula, or write down a balanced molecular formula of. So if you don't know what the different formulas mean or how to write them, then you are going to lose a lot of marks. Right, just to remind you, remember, a molecular formula is a chemical formula that indicates the types of atoms that are in the compound, as well as the correct number of those those atoms in that particular molecule. For example, over here, we have, this is a C6, 3, 4, 5. This is C5H8, okay? This is C5H8. As you can see, it indicates the compound, rather the atom that is in the compound is carbon and hydrogen. How many atoms of hydrogens are there? 8. How many atoms of carbon are there? It's 5. So that is how you write the molecular formula. The condensed molecular structural formula rather. It shows the way in which atoms are bonded together. But what is important that you need to remember is that you do not show any bond lines when you are writing as a condensed structural formula. Over here, you can see I have a CH3, CH2, and CH3. It does show you in the way in which atoms are bonded, but it does not show the bond lines between a carbon and a hydrogen. All right, very much important to take note of the difference between molecular formula and condensed structural formula. And then the last one is the structural formula. This one, it speaks to itself. You remember, you draw the structure. The moment they say write down the structural formula, we need to be able to see the structure. That's why you see that the atoms are bonded to each other, and it also shows the bond lines. You can see that it shows all the bond lines between each carbon atom bonded to another hydrogen atom. So as you can see, the difference between the structural formula, the condensed structural formula, and the molecular formula, very much important for you because you need to familiarize yourself with that language. Now, as we move on, still on question 2, what is it that you need to remember as you are practicing? Remember, there are different types of structural isomers. You remember isomers are organic compounds that have the same molecular formula. Remember, their molecular formula is the same, but what is different? Their structural formulas are different. How are they different? They're different. One, you have chain isomers. The other one is the positional isomer. And the last one is the functional isomer. Remember, I always say to the learners, when you get to this part of isomers, what you need to remember is that the definition is the same at the beginning. They all have the same molecular formula, same molecular formula, same molecular formula. But what makes them different is what makes them specific. So what makes them different here? Chain isomers, they have the same molecular formula, but different type of chains or different chain types. And then positional isomers, they have the same molecular formula, but different positions of their functional group or their side chains. Remember, the definitions are according to our 2021 exam guideline. And then our functional isomers, still again, same molecular formula, but what is different? It is the different functional groups that you must look at. Now let's look at some examples that I put or I attached here to help you remember the difference. Remember, chain isomer, you have here butane. The moment I want to draw a structural formula of butane, I remember that butane is a straight chain. But methyl propane is no longer a straight chain. Is it a branch chain? So I have two types of chain. I have a straight chain over here, straight chain, and this one gives you a branched chain. So that is the difference. They have the same molecular formula, but they are different when it comes to their chain length or their chain types rather. The other one is the straight chain, while the other one is the branch chain. So I hope you can understand why we started talking about the different types of molecular formulas and the different types of structural formula, as well as the different types of condensed formulas, so that when we come here, you're able to remember that, oh, molecular formula, what are we talking about? Okay, so very much important to take note of it. Positional isomers, we still said, remember, it's the same molecular formula, but what is different? It is the position of the functional group. Here I still have propan 1-ol, propan 1-ol. Why must I still have propan in both of them? Because I want to keep my molecular formula the same. So that means the number of carbons must be the same, the number of hydrogens must be the same, the number of oxygens must be the same. That's why it gives you the same molecular formula. Right, as you can see here, the position is not the same. One is in carbon, the OH rather, is attached on carbon number 1, and over here, the OH is attached on carbon number 2. So you can see that what is different is the position. The position was on carbon number 1, it changed from carbon number 1 to carbon number 2, or vice versa. And then the last one is the functional isomer. With this one, I like it because I have a strategy to help you remember the two pairs that work together. So all the time when you think of functional isomers when you're in the exam room, I want you to think about a cake. Why? Because it will help you remember that, an aldehyde and a ketone will be functional isomers of each other. Why? Because they have the same number of oxygens. So if they have the same number of oxygen, it makes it easy to keep the molecular formula the same. Okay? And then over here you have carboxylic acid with esters. Carboxylic acid with esters will always work together. Why? Also, they have the same number of oxygen. They have 2 oxygens each. So that means that it makes it easier for us to keep the molecular formula the same. So remember, it must be the same molecular formula, but what is different is their functional group. So here, example, we are giving butanoic acid. What is butanoic acid? It is a carboxylic acid. From butanoic acid, we can get another functional group, which is ethyl ethanoate. What is ethyl ethanoate? Is an ester. So from a carboxylic acid, we can find a what? An ester. So you see our cake works best where we are saying a carboxylic acid and an ester will always pair together because they both have 2 oxygens. Therefore, it's easy to keep the number of carbons and hydrogens the same. Very much important to remember that. I hope you can also remember that. The next thing, the biggest part of question 2 is IUPAC naming. Over here, we are not going to be doing a lot of IUPAC naming, but just to give you the tips on how to take note of the mistakes that you guys are doing when you are writing IUPAC naming. 1, the hyphens are used between the word and a number. So all the time, between a word or a letter, this is M and 2. Between the number and a letter, there always must be a hyphen in between. So it's part of the rules of IUPAC naming. The commas are used between the numbers. So between a number and another number, you are going to put a comma, not a hyphen. Remember, the hyphen is between the number and the letter. Marks will be deducted if the hyphens or the commas are omitted. Very much important to take note of that. Hyphens should not be used between words. So between a word and another word, you do not put a hyphen. You only put it between a number and a word. All IUPAC names are written in one word, right? It must be one word, except there are 2 exceptions. I know the exceptions that are there is for an ester as well as a carboxylic acid. Okay, when you name an ester, is 2 words. When you name a carboxylic acid, is also 2 words. But the rest of the other homologous series, they all must be 1 word. Examples: propanoic acid, you can see is 2 words because it's a carboxylic acid. Ethyl propanoate, you can see is 2 words because also it's a what? It's an ester. But methyl propane must be 1 word because it is a what? It is an alkane. So it's very much important. Chloromethane is also a what? A haloalkane. It's very much important to know that when you write them, you write only what you call 1 word. Now let's look at the structural formula that I have on my right hand side. Let us try to use it to help you remember some of the rules of IUPAC naming that you're going to need in this question. Right, the first thing that you do, this is how I do it. We can do it differently, but at the end we all must get the same answer. All right, so the first thing that I do, I identify which homologous series am I given. Right, over here I can see I have a bromo. The moment I have a bromo, I can see that I have a halide. That means that it's part of the halogen, which means that I'm dealing with a haloalkane. So over here, I know it's a haloalkane. So the ending or the suffix of a haloalkane is ANE. So that's how I start doing my IUPAC naming. I start by naming from the right hand side, going to the left hand side. Then after that, I'm going to identify the longest continuous carbon chain. Very much important in all directions. Then you count 1, 2, 3, 4, 5, 6. So starting to count from the right hand side to the left hand side, I get 6. From the left hand side to the right hand side, again, I get 1, 2, 3, 4, 5, 6. I get 6. So over here, 1, 2, 3 is not a straight chain. 1, 2, 3 is also not a straight chain because it does not include the halogen. 1, 2, 3, 4, 5, 6 is not a straight chain because it does not include the halogen. So the straight chain that you are going to choose, the straight continuous chain that you must, it must include the functional group. So that means this over here is going to be my chain that I have chosen. So how many carbons does it have? 1, 2, 3, 4, 5, 6. I know that 6 carbons is hex. So I'm going to write hex next to my A and E. Then the next thing that I'm going to do is to identify if I have any substituents around my chain, right? My longest chain. Actually, I do have. I have 1, 2. What is the name of these substituents? I have a methyl over here and another methyl. How do I know it's a methyl? Because it's 1 carbon is meth. It's a methyl because it has 3 hydrogens. And then over here, I have another substituent over here. How many carbons does it have? It has 2, so it doesn't become a methyl, but it becomes an ethyl. All right. Why ethyl? Because it has 2 carbons and how many hydrogens? 5 hydrogens instead of 6. So another substituent is my Br, which is over here, which I refer to it as my bromo. All right. Now, the next thing I'm going to do is I have to number my carbons. I number my carbons so that they can be nearest to the nearest substituent. So when I number, I must number in such a way that my numbering is closest, the closest substituent. So if I start numbering from the right-hand side to the left-hand side, and I'll also number from the left-hand side to the right-hand side, and finally choose the correct one. So over here I have 1, 2, 3, 4, 5, and 6. So if I start numbering from the right-hand side to the left-hand side, you can see that my bromo, which is the first substituent, is on carbon number 2. Okay, then I have my ethyl on carbon number 3. Then I have my methyls, 2 of them on carbon number 5. But I can still also number from the left-hand side to the right-hand side. 1, 2, 3, 4, 5, and 6. Now, I also have the nearest substituent as 2. So I have 2 methyl from left to right, and I have 2 bromo from right to left. So which one do I choose? The next thing that I'm going to do is to check between the methyl and the bromo, which one is more substituted. The one that is substituted is the one that has more of the same thing. So I have 2 methyls. That means that methyl is more substituted than the bromo. Therefore, the numbering that is going to win is the one that starts from the left-hand side going to the right-hand side. Hope that makes sense. So I'm going to start. This one is the one that is going to win. The one that I'm ticking is the one that I'm going to take because methyl is the one that is more substituted. Therefore, it takes preference over the bromo. Right. Then when I'm done, I'm going to arrange them alphabetically. Then I can start. I say I have my what? I already have my hexane. I know it's hexane. So I'm just going to write it down here. I already know it's hexane. So to start here, I will start with my bromo. My bromo is on carbon number 5. So I'm going to write 5 dash bromo dash. What else do I have after bromo? Comes E for ethyl, right? Then ethyl is on carbon number 4, so dash 4 dash ethyl. And then I also have 2 methyls there in carbon number 5, both of them. So I'll have dash 5, 5 dash. Okay, so I'm just gonna cancel everything here and write it here where there is space. 5 dash bromo dash 4 dash ethyl dash 5, 5 dash dimethyl. Why do I now say dimethyl? Because there are 2 methyl. Dimethyl hexane is the correct answer. Someone can say, but ma'am, what if I have started numbering from the right hand side going to the left hand side? Why am I wrong? So if you use that one, you are going to have 2 bromo. I'm just going to write both of them. 2 bromo dash 3 dash ethyl dash, then we are going to have no, this is supposed to be 2, 2. Sorry about this one. This is 2, 2. because we are using from the left-hand side to the right-hand side in the first one. Then here we're going to have 5,5 dimethyl. Methyl hexane, still hexane. Now, let's say you are in the exam, you don't know which one to choose. You know, what do? I always say to the learners, just add the numbers together. The one with the lowest number is the one that you're going to take. So we're going to say 5 plus 4 gives us 9, plus 2 is the 11, plus 2 is 11, 12, 13. So here it gives me a total of 13. This one is 2, plus 3 is 5, plus 5 is 10, plus another 5 is 15. So you can see that this one is not going to work because it is the longest way possible. We always take the shortcut. The shortcut is 13. So then hence this one will be the correct one. Guys, I hope you understood it. I know it's very challenging to name haloalkanes. That's why I took this time to make sure that you get it correct. All right, guys, we are done with that one. We're quickly going to move on to writing structural formulas from IUPAC names. Guys, this is very much important, and this is where you are losing a lot of marks. And it's very, very simple. So I'm just going to give you tips on how to draw when you are given an IUPAC name and you are required to give a structural formula. So step number 1, I want you to identify the parent name in the IUPAC name. All right. The parent name is the one that carries the weight. Okay. It's hexane, is the number of carbons. So the moment you see hex, you know that hex is 6 carbons. So I want you to do what? I want you to then start to sketch the carbons. Okay, 6 of them. 1, 2, 3, 4, 5, and 6. When you are done, you go to step number 2. Identify the functional group or the homologous series to which this compound belongs to, and use the number in front of the functional group to place the functional group on the correct atom. Right, over here, I have a methyl, I have a bromo. So I'm going to start with the bromo. Where are the bromos? I have 2 bromos. How do I know? The di means 2. Where are they? One is in carbon number 3 and one is on carbon number 5. So I already have, this is carbon number 1, 2, 3. So on carbon number 3, I'm going to have a bromo. And on carbon number 5, 4, 5 over here, I'll write it here, I'll have another bromo. Then I have a methyl. Where is my methyl? Dimethyl. How many of them? 2, which is the first one is on carbon number 2 and the other one is on carbon number 3. So I have a methyl over here. So I'm going to put a methyl here. There is my methyl. And then on carbon number 3, I also have a methyl. Sorry about going overboard. And then another hydrogen, another hydrogen, another hydrogen. Then when you are done, you put all the hydrogen. You make sure that each carbon atom consists of 4 bonds, which is this step. Ensure that each carbon is surrounded by 4 bonds, and then include the hydrogen atoms at all the opening bonds where you have. And then as a final check, ensure all carbons have 4 bonds. Ensure that when you count here, all the bonds, they give you what? 4 around each carbon atom. So that is basically how you draw it. I hope this is going to assist you as you practice for your final exam. Now, lastly, this is a typical question from a typical exam. So I just took the table that they normally give you in this question. So I didn't bring any questions into the table. I just want us to go through what we already did together so that you can see how when you practice, how you are going to practice using just this that you are given, which is the table. You don't have to go through the questions. You just look at what you are given. A, I want you to first say to me, in A, what am I given? What type of formula is A? 1, I'm given the structural formula, right? I'm given the structural formula of A. What is it do I know about A? I know that it is a alkane. How do I know it's an alkane? There are single bonds everywhere. That's how I know that it's an alkane. The next thing that I want you to do is that, what else can you tell me about this one? I can give you an IUPAC name. Okay, so I know the homologous series. The homologous series is an alkane. What is the name of the functional group? Is single bonds. There are single bonds around carbon atoms. What is it? Is a structural formula. Already said that. Now the next thing is, can I give an IUPAC name? Yes, I can. You can give an IUPAC name also for this one. All right. So that is what I want you to do. Then the next thing you say, is it this A saturated or unsaturated? I know that A is saturated. How do I know it's saturated? Because it consists of single bonds everywhere. So you do the same for all of them. You will see that when the questions come, you will be repeating what you already did with all the organic compounds that you are given. Let's look at B quickly. B, what is it that you are given? You are given the structural formula. How do I know? I can see the bonds. That's how I know it's a structural formula. The next thing you ask yourself, which homologous series does it belong to? I look at this, the OH. I know that this is a what? This is an alcohol. That is the name of the homologous series. Okay, what is the name of the functional group of the alcohol? I know it's the hydroxyl group. Hydroxyl group is the name of the functional group. Okay, what else do I know? I know that this is an alcohol. What type of alcohol is this one? This is a primary alcohol, all right? How do I know it's a primary alcohol? Because the carbon atom that is attached to the OH is only attached to one carbon atom. That's what makes it a primary alcohol. Remember, there are secondary alcohols, there are tertiary alcohols. How do you see a secondary alcohol? The OH, I can move this OH and put it over here. This will give me a secondary alcohol. Why? Because the carbon atom that is attached to the OH is attached to two carbon atoms. That's what would make it a secondary alcohol. And then a tertiary alcohol, the carbon atom that is attached to the OH will be attached to three other carbons. All right? Very much important to remember that. What else can you tell me about this one? You can give me the name. You can give you the IUPAC name. 1, 2, 3 is prop. So I know that is propan dash 1 on. Why 1? Because the OH is on carbon number 1. So as you can see, you go to each and every single one of the organic compounds that you are given, and then you open it, or you just look at it in detail like that, and you'll see that the examiners are doing the same thing. The next thing that you're going to say is that is B saturated or unsaturated? I know that it is saturated. How do I know it's saturated? Because it consists of single bonds. Single bonds around carbon atoms. That's why it's saturated. I hope we are together. Now let's quickly look at C. I'm not going to do all of them, but I'm just going to do C. Okay, C. What type of formula is C? Is it a structural formula? No, it's not a structure. So what is it? It's a molecular formula. I know that C is a molecular formula. So from the molecular formula, can I write the structural formula? Yes, I can write the structural formula. So I'm going to do it over here. So bring it here. Can I write the structural formula of that one? Yes. Okay, I have carbon C4. 1, 2, 3, and 4. What do I have? I have 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. Tells me something. That means the double bond of oxygen will be here. Then I put my hydrogens everywhere. Okay, once I'm done doing that, I know that, okay, now I can see clearly if this is an alcohol or if it's a aldehyde or if it's a ketone, because those are the only 3 that only have 1 oxygen. So as you can see clearly from the structural formula, I'm able to see that, oh, the name of the homologous series is the aldehyde, okay, because of that. And then the next thing, what is the name of the functional group of the aldehyde? I know that I'm dealing with a formyl group. All right, it's a formyl group. What else can I know about this aldehyde? Or I can give a IUPAC name. 1, 2, 3, 4 is but. So it will be butan-1, butanal actually. It will be butanal. Why am I not putting a 1? Because the aldehydes will always be on carbon number 1. This will always be on carbon number 1. So there's no need to put a 1 in between the N and the A there, because they're always going to be on carbon number 1. What else can I know from here? Oh, aldehydes, I know something. They can form functional isomers. What functional isomer can I form? I can form a ketone from this. Okay, what type of ketone? Okay, can I draw the ketone? Yes, 1, 2, 3, 4. I have my ketone. There it is. I still have the same number of the molecular formula and Same molecular formula, but different functional group. So that tells you that I can form a functional isomer. So that is how the examiner is asking the question. You can see that we didn't even go through the questions. We just looked at the table itself, and the table was able to tell us what the examiner can ask. They can ask what is the general formula of what? Of C. You must know what is the general formula. Is it saturated or unsaturated? I already know that this one is saturated. So those are the things that you need to do for all of them. That is how you deal with question 2 as you practice. I hope this is going to assist you. Guys, we have come to the end of question 2. We are quickly going to move on to question 3. In question 3, we are dealing with physical properties of organic compounds, which are 3. There are 3 physical properties of organic compounds that you still need to remember, and you also need to be able to define them. Boiling point, melting point, and vapor pressure. Guys, please go look at the definitions according to our exam guideline. And repeat, it is the 2021 exam guideline that we are working with. Go look at it. Now, what is the relationship? Let's help you remember. What is it that you must remember about these 3 physical properties? Is their relationship. The higher the boiling point, the higher the melting point, and the lower the vapor pressure. How do I know if the substance is going to have a higher boiling point, a higher melting point, or a lower vapor pressure? I'm going to compare the type of intermolecular forces or the van der Waals forces. So do not be surprised when you see the word van der Waals forces on your question paper. It's just another word for intermolecular forces. So we have 3 intermolecular forces to help you remember. We have the London forces, dipole forces, and hydrogen bonds. Remember, we have arranged them from the weakest to the strongest. We have London forces that are weak. These are weaker. This we can say this is strong, and then this one is the strongest. Okay, this could be weak, strong, and strongest. Okay, remember, in order for you to be able to know which organic compounds consist of which intermolecular forces, I have made an abbreviation for you here that will help you remember. AAA HAC will help you remember which one belongs where. AAA is alkane, alkenes, alkynes. These are your London forces. HAC is haloalkane, aldehydes, ketones, and esters, and these are your dipole forces. And then AC, this is your alcohol and the carboxylic acid, and these ones are your hydrogen bonds. Remember that the dipole forces also consist of the London forces. It's just that the dipole forces are dominant in haloalkanes, in aldehydes, in ketones, as well as in esters. Those are the ones that stand out. Hence, we put them forward as dipole. Then, under alcohols and carboxylic acid, they still consist of London and dipole forces. However, the strongest intermolecular forces that are present in them is hydrogen bonds. Those are the ones that are more dominant. Remember, alcohol, they have one side of hydrogen bond, and carboxylic acid, they have 2 sides of hydrogen bonds. And between the two, which one is the strongest? It will be the carboxylic acid, because it has the 2 sides of hydrogen bonds. I hope you guys still remember all of that. You can go back and revise. The next thing that I want you to look at in this question is the differences between the dependent and the independent variable, because the examiner sometimes likes to make this question an investigative type of question. If it's an investigative type of question, always remember the dependent, independent, as well as they can ask you to write an investigative question. Now, under dependent variable, we know that we are talking about what we are investigating. The dependent variable will always be either the boiling point, the melting point, or the vapor pressure, because the boiling point, the melting point, and the vapor pressure, they depend on something in order for them to either increase, decrease, or remain the same. Now, what do they depend on? Those are the independent variables. They either depend on the homologous series. If you have different homologous series, then you know that the homologous series are the ones that are going to determine if the boiling point will be higher or lower. And then if not homologous series, functional groups can also be a what? A independent variable. Or you can just say the intermolecular forces. Because if they have different intermolecular forces, according to either which one is the strongest, that's when you will know which one will have a higher boiling point. By the way, the stronger the intermolecular force, the higher the boiling point, the higher the melting point, and the lower the vapor pressure. I hope you guys still remember that. Now, if you are given substances that belong to the same homologous series, how will you identify if which one will give a higher boiling point or a lower boiling point? You are going to look at their chain length. You are going to compare their chain length, will be their independent variable. Their surface area will be their independent variable. Their molecular mass, okay, can be their independent variable. That is what is going to help you to see if the boiling point will be greater or higher. All right, we'll look at some examples shortly to help you remember. Then lastly, the examiner can say to you, fully explain why the boiling point of this particular substance is higher or lower. So what is it that we are looking for? I've written ice for you to help you remember. What is it that we are looking for when we want you to explain? Remember, when I will stand for the intermolecular forces. Talk about the intermolecular forces that are present, okay, in each organic compound. Is it London forces and hydrogen bonds? Is it dipole and hydrogen bonds? Or is it all London forces? So identify the intermolecular forces that are present. Then the next thing, I want you to compare the strength of the intermolecular forces. Intermolecular forces. Please do not compare the organic compounds, but you are comparing the strength of the intermolecular forces. And then E, you talk about the energy required. Energy required to overcome what? The intermolecular forces. Very much important. Then the next thing, you tell us if the boiling point is going to increase or decrease. All right, what is it that you must remember? The stronger the intermolecular force, the higher the boiling point. Okay, the longer the chain length over here, the strength of the intermolecular forces becomes stronger. The larger the surface area, the strength of the intermolecular forces becomes stronger. The greater the molecular mass, the strength of the intermolecular forces becomes what? Stronger also. Right, I hope we are together there. Now let's look at an example. I'm just going to give you 2 minutes to try to go through this one, and then we will do it together. All right. Now, welcome back, guys. Let us quickly see what is it that we are given here. We say we have a learner conduct a scientific investigation to compare the boiling points of organic compounds belonging to different homologous series. Propan-1-all, ethanoic acid, propanol are used for this investigation. Here's the result in the table below. Right, we have compound A, B, and C. We have the boiling point here. Right, what do we know? The higher the boiling point, the stronger the intermolecular forces. The first thing that you're going to see is that, okay, I'm given different homologous series. Different homologous series belong to different intermolecular forces. Okay, so propan-1-all is an alcohol, belongs to hydrogen bonds. Okay, hydrogen bonds. And then what about ethanoic acid? It's also hydrogen bonds. Hydrogen bonds. But this one has what? 2 sides. And this one has 1 side. Okay, and then we have propan-1-all, which belongs to dipole forces. Right, then we say to us, if I look at this compound, which one will be the one with the highest boiling point will include the one with the strongest intermolecular force. And in this case is ethanoic acid. So this one will be our ethanoic acid, followed by our propan-1-all, and then lastly our propanol. Right, I hope we are together there. Now we look at the question 3.1 says, for this investigation, name the independent variable what made the change, okay? What made the boiling point to increase or decrease? It is what? It is the type of the homologous series. Can you see there are different homologous series? So you can say either homologous series, because they are different, or intermolecular forces, or you can say what? A functional group. All right. So any of those could be the independent variable, even though the hydrogen bonds is the same for propan, one-all, and ethanoic acid over there. The difference is the other one is one side, the other one is two sides. The dependent variable is what you are investigating. What are we investigating? The boiling point. So the boiling point will be our dependent variable, because the boiling point depends on the homologous series. Homologous series belongs to a certain intermolecular forces. The stronger the intermolecular force, the higher the boiling point. Hence, it becomes a dependent variable. Now, another thing that I want to talk to, which is not here, is the investigative question. The examiner can ask you to write the investigative question for this. So the investigative question, what is important, it must always include the dependent and the independent variable. So in this case, we can say, what is the relationship between the boiling point and different homologous series? Or what is the relationship between the boiling point and different functional groups? Or what is the relationship between the boiling point and different intermolecular forces? And then don't forget that when you are asked the question, you must always include a question mark. Guys, we are okay with this one? If they ask you to fully explain, say they say to you, compare compound A and compound B, fully explain why propan 1-all will have a higher boiling point than propanol. So what do? You do our ISO. I always say you can use a table, it's easier. So this side I can write propanol, this side I can write propan 1-all. It's easy. Then what do I talk about? I talk about my ice. What is my ice here? Propan 1-all here. I know I have dipole forces. Dipole. This side I have hydrogen bonds. Then C, I compare now. What am I comparing? The dipole with hydrogen bonds. So I'll say weak dipole. Compare the intermolecular forces, not the compound. And then this side will say stronger hydrogen bonds. Okay, then lastly, we talk about the energy required to overcome the intermolecular forces. This side we will require less energy required to overcome the intermolecular forces. This side is more energy because the intermolecular forces are stronger. So you need more energy required to overcome the intermolecular forces. There you have it. You have your total marks. Now let's quickly move on to a different way in which the examiner can ask the same question, but using the trend. Okay, that means here the examiner is using organic compounds that belong to the same homologous series, meaning they have the same homologous series, they have the same functional group. Okay, they also have the same intermolecular forces. So what do you look for? Look for the chain length, look for the surface area, or the molecular mass. Let's look at this one. A, B, and C, they are all alkanes. Can you see they're all alkanes? They all belong to the same homologous series. So they are all London forces. So how do you explain the trend? I already did it for you. You're just going to say increasing in chain length from A to C, or you can say there is a decrease in branching from A to C. Then increasing in the strength of London forces from A to C, we can see that the strength of the London forces are going to increase from A to C, because as you can see, the boiling point is also increasing from A to C. and then say more energy will be needed to overcome the intermolecular forces. Thus, the boiling point will increase from A to what? To C. So that is a different way in which you can be asked to answer this question. All right, guys, I hope we're still together and you are happy with what we have done so far. We are quickly going to jump on to question 4, which is normally types of reactions under organic compounds. It is still under organic compounds. So we're just going to touch and go. We're not going to do everything. We're just reminding you. Remember, guys, there are 5 types of reactions that you need to know. The first one is esterification. This one is easy. The process whereby an alcohol reacts with the carboxylic acid in the presence of concentrated sulfuric acid to form an ester plus water. So I've done for you over here an abbreviation to help you remember as you study. A is plus water. A is for an alcohol. There is an alcohol will react with a carboxylic acid to form what? An ester. There's my ester plus what? Plus water. Okay, so that is how I can help you remember the process of esterification. Now, what is important is the reaction condition that this reaction takes place. Remember, we need concentrated sulfuric acid acts as a catalyst in this reaction to speed up the process. Very much important to remember. The reactants, we said it's alcohol and the carboxylic acid. In this case, we have 1, 2, 3, 4. We have butanol. Butan 1 all. Okay, and during the process, hydrogen is removed from the alcohol, OH is removed from the acid. These two, they combine to react to form what we call water. Then whatever that is remaining, they join together. As you can see, that oxygen is still there, and then we swap the carboxylic acid around to attach to what was initially the alcohol, and then they form our co, which will give you that ester. Hope we are still together. What is the name of the acid that was used? 1, 2 carbons. That is ethanoic acid. All right, this is the type of the questions that the examiner can ask you. What is the name of the alcohol that was used to prepare the ester? What is the name of the acid that was used to prepare the ester? And what is the catalyst that is used in the reaction? All right, the balanced equation using structural formula or using molecular formula. So you also need to be able to do that. And then secondly, we are going to jump on to oxidation. This one is also quite easy. Here we are only going to focus on the oxidation or the combustion. Oxidation and combustion is the same thing, okay? So we are going to look at combustions of alkanes only, okay? This is where an alkane reacts with oxygen in the atmosphere to form the same products will be formed over and over again. And those products are carbon dioxide plus water. So very much important. You take whatever alkane that the examiner has given you. What you just need to do is to react that alkane with oxygen, and then the products are the same, which is carbon dioxide plus water. What will be remaining is for you to balance the formula. If balancing the equation is a problem, you can still get 2 marks instead of 3. So you'll get 1 mark for reacting with oxygen and another mark for the product. And then the last mark is for balancing the equation. If you don't know how to balance, it's not a train smash. At least you can get a 2 out of 3. I hope we are still together there. I said you are reacting an alkane with oxygen to give you carbon dioxide plus water. And then this is when actually an alkane is burning in the air. That's why it reacts with the oxygen and forms that carbon dioxide plus water. I hope we are together there. Then we are quickly going to jump on the other type of reaction. Here is the addition reaction. So there are 4 types. Remember, 4 types of addition reactions only: hydration, hydrogenation, halogenation, and hydrohalogenation. Now, this one, we are not going to talk about the details. What you need to remember, what you look out for. Look for an unsaturated reactant. All the reactants will be unsaturated if you are dealing with an addition reaction. Remember, unsaturated means that it has multiple bonds between their carbon atoms. Okay. Then what you are going to be looking for is a saturated product. So in our product, you can see all my products are saturated. You can see an alcohol, alkane, haloalkane, and another haloalkane. They are all saturated. So the moment you are moving from an unsaturated reactant to a saturated product, then the type of reaction there will be A for what? For addition. Okay? Addition reaction. That's all. And then what you need to do is go study your reaction condition for each reaction. Very much important to do that. Then we are quickly going to say to you, as you do that, please do not forget Markovnikov's rule. Go and revise Markovnikov's rule. Remember, it indicates that where it was a double bond, let's take this example of hydrohalogenation, where we have an alkene reacting with a hydrogen bromide to form two products. One is a major product and one is a minor product. So when you are following, remember, when you're following Markovnikov's rule, you are looking at the major product, not the minor product. But all the time when you are doing your drawings, always write a major product, unless the examiner indicates that they want to see a minor product. If they don't indicate they want to see a minor product, always give us a major product. So what happens during a major product? You can see here it's an addition reaction. I'm adding a hydrogen and a Br where the double bond was. So I go back to my two carbons where the double bond is. I check which one has more hydrogens. Carbon number 1, carbon number 2. Carbon number 1 has 2 hydrogens. Carbon number 2 only has 1 hydrogen. Markovnikov's rule says you are going to place this hydrogen to a carbon that has more hydrogen. And you are going to put the Br to a carbon that has less hydrogen. So always say the rich to the rich, the poor to the poor, meaning you are putting the hydrogen where there are more hydrogen to make that carbon rich with hydrogens. And then you are going to put the Br on the carbon that has the least number of hydrogens. And then that will be your product over here that will always give you a major product. A minor product is the vice versa. You are actually putting the Br where there are more carbon, more hydrogens, and you are putting the hydrogen where there are less hydrogens. Right, I hope we are together there. Then we are quickly going to move on to the next type of reaction, which is elimination reaction. Remember, under elimination reaction, there are only 3 types that you need to go back and revise. It's cracking, dehydrohalogenation, as well as dehydration. What you must remember is that when you are dealing with elimination, you are looking at a saturated reactant. You can see alkane, haloalkane, alcohol. They are all saturated reactants. But when they react, their product will be unsaturated. Alkene, unsaturated, alkene, unsaturated, alkene, unsaturated, unsaturated. This is supposed to be alkene again, unsaturated. Right, so when you are moving from a saturated reactant to an unsaturated product, therefore the type of a reaction will be elimination. Then the next thing you're going to be looking at is, what did I eliminate? Remember, elimination means removing something from a formula. Now, what is it that you will be removing? And then the next thing, do not forget your reaction conditions. Very much important. Then lastly, the last type of reaction that we are going to be looking at is substitution reaction. Remember, there are 3: halogenation, hydrolysis, and substitution. Only 3 that you need to know according to your exam guideline. Then what is it that you are looking for? You are looking for a saturated reactant. You can see alkane saturated, haloalkane saturated, haloalkane saturated, alcohol saturated. Now you are moving from a saturated reactant to a saturated product. You can see product, saturated, haloalkane, alcohol, haloalkane. They are all saturated. Saturated reactant to a saturated product, the type of reaction they will be substituting. So substitution rather. Then the next thing that you are going to look at, what is it that I have substituted with? And then please do not forget your reaction conditions. Please go look at them. They're very much important.